All right, guys, so we are going to implement animations now. There's a couple things that we got to think about when we're doing this. It's not really hard to code because we've done a lot of the background work, the creating the different states. Really now we just need to look at the animations and see how to implement them in to P5 Play. So let me pull up the animations that I have, and your guys's, depending on the state that you have your animations and how you're doing it, you may end up having to do this a little bit differently. So I'm going to kind of talk about it, mentioning P5 Play, but also mentioning how, different concepts that we need to think about as we're going through this. Okay, so if you guys were building with the Piskel app, there's multiple different ways that you guys could pull the different information out. We don't want to do a GIF. We could try to do a sprite sheet, but it was only creating one sprite sheet for that one set of animations. Now, this really is kind of the better way, is that if I open up animations and I have them separated as a single frame, then I can go in and build a sprite sheet. So this is a die animation, and it is several frames. It's a total of 9 frames, and then we go to a different one. Okay, so what I'm going to do is I'm going to start implementing these, but we need to use basically a program to kind of pack those images together. When we start playing around with assets, we have to be mindful of the amount of space that we're going to be taking up and how long things take to load. And if I could certainly use just all of these different images by themselves, load that into P5 Play, get my animations running. I want to show an example of why this is not good, though. Let's see. Okay. So if we load them separately instead of a sprite sheet, this is what we end up seeing. We have all of our different animations in here. Then we have our classes that we use to build our structure. And all of this really kind of gums up our organization of where all these files are. And we might end up having multiple files that have very similar names, like an enemy walk here and another enemy walk. And then I end up having to deal with repetition of file names. This just becomes problematic. But if we have a single sprite sheet, and this is what a sprite sheet looks like. A sprite sheet is in many games where you can either have it by, say, a specific animation or the entire character or all of the assets of your video game, which is ultimately the goal. I want to be able to look at each asset of my video game, implement that into a sprite sheet, and then I only have to load one image, and then I can pull the parts that I need as I need them from the sprite sheet. So look, if we look at this is for Mega Man, they have different animations. Now, the way that they built these are vertical. So look, this is one animation, this is one animation, this is one animation, this is one set of animations. So like this is his run, this is his jump, this is his like slide. And we could build it like that, or you might end up seeing something where they're broken up by rows. That is a row is animations. Here's another row. And if you notice this one, the major difference between these is that we got a lot of spacing in between these. So what we want to do is we want to kind of look at whatever library or game engine or whatever that we're using to find out what type of format is it best designed to pull stuff in, and then kind of set up our sprite sheet so that we can meet that. That would ultimately make it the easiest for us to implement. So I'm going to go to P5 Play, and I'm going to go to animations. Okay, so first thing that I see when I'm looking at P5 Play is that there are 3 different ways that we could load images to do animations. We have a sequence mode where I can pass the first file in a animation and then give the last frame index number of the file, just like what we've seen here, that they all have these numbers. It will go through and pull itself. Okay, second one, list mode. I can just individually put a list of all those images, and then I can set up the animation. The third way is that we could do a sprite sheet. And the sprite sheet, we could pass information, an atlas object. So we load the sprite, and then we can load specifically what size I want each frame to be and how many frames I have, if I want to delay them, all of that stuff, and then have the animation run. But it's actually pulling each one of these individual images in sequence. Okay. Now I have a lot of controls with P5 Play, and a lot of other systems you end up having controls to be able to start, stop, play, pull up a specific frame, slow down your animations, rewind, loop them. I could even scale them to different sizes. I could give the amount of frames that I have in my animations. So we need to look at that. We're going to have to implement our stuff with that. Now here they have sprites with animations, so we can create a sprite, and we could put animations on there. They do have, let's see, so they have an add Annie and a load Annie function. Now the add Annie is to add the animation, and it's just like preloading. Now if you want to use it right away, you might want to preload your assets and then pull from them, which is going to be kind of what we're going to ultimately do. And then when we want to change an animation, we can just call on the sprite itself to change the animation. We could mirror it horizontally or vertically. Let's go down more. Okay. Now, since we have multiple different frames and different animation sets that we need, ultimately we want to put this all together. So if we can see something that already has kind of an implementation with a major sprite sheet and not just one animation, but many, that may be what we want to kind of emulate while we're building it. So this looks like they're loading a sprite sheet, okay, and they're adding animations from the sprite sheet using an atlas object. So I'm seeing the examples here, and it's showing kind of where it's pulling those frames for each animation. Okay, now using this, I'm just going to check some things. If I press J, that's doing the jump animation. I just keep going and doing that. Now I see on the sprite sheet, I'm on a different row. Let's do a different button. L. That's a different row up here. T, different row. S, that's stand. R, different row. Okay. And when I look here, I see that they're adding a sprite sheet. They're doing any type of offset or delay. It looks like we can do it directly to the animations them as a whole, or we could do it individually to the animations. We can add the animations. Here they're adding it like an object where I can give it a name. I can give it different atlas information, and that's what we have here. And then I can run it. So, okay, the major thing that I see here is that I see that we're giving row and we're giving frames for doing the animations. But it says that we could also do columns. So just with this way that they have it here, it looks like it's kind of geared towards reading horizontally. So that means that I need to build mine so that it's reading horizontally. Okay, so then I'm going to come here and I'm going to start building these animations so that I can pull them individually. So I'm going to go to each one. Let's see, I'm going to do my die. I'm going to select the first one for that, and then the last one. Ooh. Hold on. I could need to log in. It's not letting me select stuff. Okay. There we go. All right. right, so I want to select all of these at a time instead of downloading them individually. I'm going to just right click and click download. So we have a die. We know we need an idle. So I'm going to put this here. I'll give it a folder. Let's just say I just call it Ninja Animations. Oops, I should have probably renamed that. That would make things easier. I'm going to do idle here. I'm going to do all the idle animations. I got them all. This one I'm going to make sure to rename. Download. Let's do jump. Let's save jump. This one's idle. Okay. I already built a hurt one for you. Let's go ahead and download that. That one's set up as horizontally. Okay, run. Let's do that. Okay, and then I have weapons, which these are just individual weapons. So ultimately, when I want to finish my full sprite sheet, I'm going to put all of these things, the smaller size stuff, but I'm going to want to do that probably at the bottom of that sprite sheet so that it's easy for me to calculate, or I might have it on a separate sprite sheet. Okay, so now we have started pulling those images, and if you ended up already having a sprite sheet that you needed to make changes to so that you could switch from horizontal to vertical, it's possible, but we may end up having to hack it up. So I have two different tools that we can use. I have a texture packer to put a sprite sheet together, and an online sheet cutter where you could cut it up based off of your frame size, and then individually pull those frames in that you needed to use and can ignore the ones that you don't. So I'm just going to open up the texture packer though, and to orient you to this, a texture packer is really a way that we can take individual images. This is for individual images. We can put them together to form a sprite sheet. Okay, now right here, this is just forming a run animation. I can download this and then label it, say, run animation, and then put that on a bigger sprite sheet so I could kind of stack all of them. So there's lots of different ways to do this. I could also use a JSON file, which is a data file, stands for JavaScript Object Notation. I can use this to actually read and understand the image and be able to pull the images specifically from where they are. Maybe I want this or this one to do different things. Now, what we've seen in P5 Play, nowhere did it have any implementation of a JSON file. So this could still be used, but for ease of use, what we see is as long as we have on the rows, it looks like it's fairly easy to implement. So I don't need anything overly complex, but I do need to build this. Okay, so now here's the settings, and we can click on the settings to be able to see the settings at any time. If we click on an individual frame, we can say what the name is and where the coordinates are, okay, which will give us an idea of the size of each individual frame. Okay, now ideally when we're building a sprite sheet, all of them should be the exact same size. Personally, I think all padding should be removed because we want to be able to calculate. If I know, like looking at this one, that it's positioned at 128, then I know the width of this is 128. The width of this is 128. So I could calculate where this one is going to start at because it's going to be 128 times 2. Which would be 256. So if I go here, if there's no padding or anything, it should be predictable that that's 256. 256 plus 128 would give me this one. Okay. Now if I add padding to it, though, it's not the case. It's harder to predict because it's adding padding at the start and end of each frame, top and bottom, and you don't know how many pixels it is. So it's a lot harder for you to calculate out. Rather than just saying, okay, they're 128, I have 4 of them, I can find out what would my position location be for my next one. Okay, so we're going to make sure that padding is at 0. Now, since we've seen them built by rows, we're going to start with a horizontal layout. So I'm going to do this for each of the animations. I'm going to go in here to my downloads. Go to my Ninja animations. And I have these currently zipped right now. So let's go ahead and open this one. I need to extract it. If you ever have a folder or set of files that are zipped up, you're going to have to extract them before you can use them. Okay, so let's extract them out. Now for Windows, you really have to just right-click and click Extract or Extract All. We cannot load or read zip files into many different programs. You're going to have to extract them. Okay, so that's my die. I have an idle, a run, 1, 2. I did not do my jump, and I got my hurt. 4. Okay, so let's start loading these in. So I'm going to add sprites, and I got to do this one at a time. So I'm going to come in here. There's all of my die animations. Put them in. It's already set to horizontal. I don't have to worry about the data format, but each one of these, see how they're individually put, and I can see the size of them. So I know that this is 700. Okay. Now, if you were doing this and you wanted to make sure that you were really close for collisions, you could make sure that you don't have any boundaries around so that you're tight with your shape. Making sure, though, that it has the same width and height does make it a little bit easier. Okay, so this is all of my die animation. This is actually done as long as I check my settings. It's horizontal and the padding is 0. Now I can go ahead and download this. This is a whole animation, so I can save this as a die anim, short for die animation. Okay, now I can build another one, but I'm going to have to clear this one out first. So let's go ahead and build another one. I'm going to go to my idle, do that. The order doesn't really matter as long as when I'm writing in code, I'm making sure I'm being very specific about which row I'm looking at. So this one is my idle, anim, making it so it's easy for me to find it. Okay, clear this one out. Let's do another one. So we had die, we have idle, we have run. Let's do a run. Run, anim. Okay. And then I have my hurt one, which I already did. It's already in this format. Now let's look at our jump. Okay, based off of how we built our code, we have 2 different states for our jump. We have a jump where we're going up. We have a fall where we're coming down. Okay, those are 2 different states. So that means that our jump really needs to be broken up into 2 different states. So let's look at our jump and see what we got. Okay, so I see 6 full frames. Now, I'm thinking kind of design-wise in terms of a jump. So sorry, having my hands move. And then I kind of have them come back. So in terms of that, I'm going to look at, well, my jump, I'm moving up slower and I can come down faster. So I'm probably going to use like 4 frames of the jump for a for the jump where I'm going up, and then I'm going to use 2 frames, the last 2, for going down. So let's go ahead and download it, but that's how I'm going to build it. I'm going to build it as 2 separate ones. So let's call that jump. Now we can come back here. Let's clear this one out. the jump, but I'm only going to add the first 4. And we could probably do this programmatically too, but there's multiple ways to do this. So I'll call this jump unim, and then let's do our last 2. I'm going to clear this one out, and then do the last 2 here. And that'll be my fall. Fall unim. All right. Okay, so I've pulled all of them. Now I want to make them so they're all kind of built by rows. So let's clear out. I'm going to start adding these. So say I add my die first. If I keep it as horizontal, it's going to add it all on one line. So if I did another one now, I did die, let's do fall. It did do it, but it's all the way at the end here. And based off of what we've seen in P5 Play, they have the animation set up as different rows. So how would we do that with the texture packer? We would switch the layout from horizontal to vertical. Each individual image is on its own row. Now, the reason why I created all the animations on one and then downloaded it and then put it in again as a whole, because it's treated as one thing, so it makes one row. There's my second row. Regardless of how long or how many frames, it's created as one row. If I add another one, so that was my fall. Here's my jump. Here's my jump. Okay, so let's add the rest of them. I can add multiple at a time. So I have my die, my fall, my jump. Let's do my idle. And I have my hit. And I have my run. Those are 3 separate ones. I'm going to click. And it will load them. There's my different animations. Okay. So I'm going to download this. And this is my spreadsheet. Okay, let's look at my spreadsheet. If I open this up, I should see all the different rows. That's what I see. That's awesome. Now, with any of them, I should be able to check out the info, find out the file size, and find out the full image size. Now, this is the composite image size, so it's this plus this plus this plus this plus this plus this. Okay, working my way all the way over. So there we go. Now, let's start implementing this in now that we have a spreadsheet. So we're going to implement just like what we've done with our sketch, where we have loaded a spreadsheet. So I'm going to take my spreadsheet, I'm going to upload it here. Now, depending on what system you have, you may end up having too big of a file, and it won't want to load all the way, or it'll error out. Mine actually says it's too big. Okay, so let's look at ways that we can solve this. Okay. The image size that was 700 by 700, I need some way of shrinking this down. Now, with most of them, there's usually an option to resize the images. Really, most of the time, directly in the view when you're looking at it. So let's see what we can do. Save, because usually they have some type of resize image option. Crop, remove background. Let's see about file save. Let's see. Scale document down, scale document up, share the document. All right. That just resized it. That didn't actually resize it. if I just save, it did nothing. I want to resize the image. Adjust size. There we go. Let's do that. Okay. I could do it by inches. That's not really helpful. We could do it by pixels. That's better. I think going by percent would be even better. Okay. So if we shrink our image down, let's say, so it's 50% smaller than what it used to be. That's way smaller than what it used to be. Okay, now I could look at what is the size of the object that I'm going to put my images on and then scale appropriately. You could do that directly here, or you could do that programmatically. I'm going to do it programmatically just so you guys can see if your image sizes weren't exactly fitting your objects, what to do. So we're going to size that down by 50%. Now we know that's going to be a much smaller file size. That should now work. Okay, so I'm going to go back in here and I'm going to try to load that sprite sheet again. And this should be a much smaller sprite sheet. See, it's showing much smaller size. No issues with it loading. That's good. Okay, now I want to make sure that it's a really easy file name to load. Sprite sheet, that's easy enough. I have to have a variable to hold it. Sprite sheet. I'm going to have to use a preload, so let's go ahead and do that, preload, and just load it the same way as what we've done images before in the past. Now, if I ever wanted to edit this sprite sheet, as long as I keep the name, it will make things easier. As long as I keep the order that I originally set up these animations, and when I want to add enemies and other stuff, I will just maintain the same order, and then I can put on the sprite sheet, or I could just actually add those two sprite sheets together. That should make things easy enough. Okay. All right, so we have a sprite sheet. We loaded it here. I need to start thinking how I'm going to design this. Now, for the sprite sheet, ultimately, I'm going to end up needing to pass the sprite sheet along to every creature that has stuff, and then it's going to pull its responsible frames out of there. So for right now, we're rapidly prototyping with the player. We're going to add a sprite sheet and work it in with every single character. So for my player, we're going to have to pass in a sprite sheet. Player is built off a dynamic creature. So let's go to dynamic creature. Part of its constructor is now going to require a sprite sheet. Now, the way that I'm going to do this is that I will keep passing the sprite sheet until I find the sprite, because that's what P5 Play uses, is that it was loading the sprite sheet into the sprite itself. So dynamic creature, I don't need that sprite sheet, so I don't need it here, but I do need it in the super to pass it up to the dynamic class that it inherited from. So I'm just going to keep passing it up, go to my dynamic. It now requires a sprite sheet. And actually in here we can clean up a little bit of our code also. So I'm going to have to do it after I create the sprite. I'm going to have to load the sprite sheet. So this .sprite sheet. Notice the casing. It's capital S. Right here, capital S. Okay, sprite sheet is that sprite sheet that I just passed. Okay, so that gets us started. Now, a couple things. When we were designing this, we had the position. We were passing it in as a dynamic object, and then we were holding on the position. And then we also had our sprite holding on the position. That's really how we were moving. So we actually have a little bit of redundancy in here. We're passing the position in, holding it here and doing nothing with that position, but then after we initially pass a position in, the sprite is the one that's controlling it. So I'm going to actually refactor a little bit. We do not need this anymore, but we need to pass in position directly to here. So we don't need to say this dot. We just need to pass in the position, pull the X and Y values. All right, I've passed in the sprite sheet. Now I'm going to go to P5 and look at how they're building animations, and then I see how they have the change Annie, so I'm going to want to do that. So the sprite is adding the animations, and then we're labeling them. Let's build that out. This dot sprite dot add Annie's, and then they were labeling by row. So I'm actually going to look at my sprite sheet, and I need to do it specifically by row. So this one is my idle. Then I have my die, then my fall, then my jump, then my hit, then my run. Okay, so idle, die, fall. So I need to build it in that way. Idle is, let's see, it's on row 0. And it has how many frames? Look back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So it says 12. And then we got a comma, and then we're doing our next one. Okay, so I'm going to do this. I'm going to write this using kind of multi-cursor select so we can make this easier. So we got 2, 3, 4, 5 more animations. It's going to have a name, then it's going to have a row, then it's going to have a set of frames, and then it's going to be finished with a comma. Okay, so next one we had was die 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So die row 1 frames 10. We're going to the next one, fall row 2. Next one is fall. Let's add that. That was row 2 frames 2. Then I have jump, hit, and run. Jump, which we know had 4 frames. Hit, and run. Okay, hits 5, run is 1, 2, 3, 4, 5, 6, 7, 8. All right. 4, 5, 6, 7, 8. 8, and I think this one was 6. Let's double check. 5. If we're off on the amount of frames, we're going to get like an empty frame in there. All right, so this should be good. Let's look in here. What do we have? All right, so we have that to change the animation. We have an offset. We have frame delay. Okay, so in terms of what we're going to do, we're going to go in each of our states. We do know that idle starts first. So let's go ahead and write this dot subject dot sprite dot change Annie. And we're loading the idle animation. Okay, and then I'm going to copy this, and we're going to do this for each state. So when we enter the fall, we're going to enter into the fall animation. When we enter into our jump, we're going to enter into their jump animation. We go into our run. We're going to go into our run animation. Okay, I don't have a hit state and I don't have a die state because we don't have any enemies implemented yet, but we're getting there. So getting this should help. Awesome. Now, if we ever get a fail to fetch, ways that I found around this is that we just have to actually open it up in a different browser and we can get this to work. Okay. So I'm going to continue going on, and then I'll pause it and go to a different browser when we go to test. Okay, so now that we have that, okay, now what I had to do, I actually had to delete the image and then reload it, but I have it. Now, what I'm seeing is I'm seeing a lot of stuff. I'm seeing kind of all of my animations are kind of all over the place. All right, so what we're going to do is we need to kind of debug a little bit before we move forward anymore. One of the things that I do see is that when I'm reading here in the documentation, it says in the hero example, the size of the hero sprite is set to 32 pixels by 32 pixels by the sprite constructor right here. Now we set directly our sprite constructor, we set our diameter directly, but all my images seemed really big. So we need to kind of delve down on that a little bit. Now, one of the ways that we can do that is we can actually look at our actual collider, and we can do that in the setup. We can make a couple changes. One of the things that we could do is we could talk to all of the sprites that are ever created in our game. They automatically go in a group right here, and we can actually look at its debug value and set it to true. The benefit of this is that every single object that is a sprite will show its collider. Oh, I don't see that. It should show as a green outline, so we're just going to kind of wait a little bit. Okay, now we see the green right there. Okay. Another way that we can do this is that we can actually do that directly on the sprite itself. So we could do it in dynamic itself. What I believe is the first issue is that we don't have our sizing properly. We don't know how to cut up the sprite sheet, or P5 Play does not know how to cut up the sprite sheet. So we got to actually pass that in. Now, since we took our image and we cut it in half, really, since we knew that it had a width and a height for each frame of 700, and then we cut it in half by percent, then the width and height of each frame should be 350. Okay, so let's start kind of playing around in that. We're going to go to dynamic, and we're going to take our idle. We'll just start here, and then using what we see here, I see width, height, size, or frame size, all of those basically kind of doing the same thing. I'm going to add a frame size and give it, let's say 350 by 350. You're going to have to know what that size is. If you guys don't know what that size is, all you have to do is just open up a single frame of one of your animations like this. We can go to, say, the jump animation. I can open up a single one and then look at the information for it. It tells me what the image size is. Okay, so not too hard to do it with your guys' current animations. So we changed the frame size. Now we see him, and I'm not seeing the sprite sheet, so that's good. Okay, but look at how big that collider is. That is massive. Okay, and for me, it's a little bit harder to see because I'm seeing the ground too. So I'm going to make a small tweak. Instead of doing that here, I'm going to comment that out. I might want it later. I'm going to go to dynamic, and right after sprite, I'm going to say it. So this dot sprite dot debug equals true. There, now I see it. But it looks way too big, okay? So it seems like whatever one is giving a size last is the one that it takes. So I am going to move my sizing of my collider, the size of my sprite, to after I do my animations. Let's see what that does. There's my collider. And now look at my character is moving weirdly. Okay, so once we set the frame size, it looks like we're good. We're going to have to size our animations down, so we're going to have to see like what ways we can do with that. But my collider's working. And it kind of looks, it's kind of hard to tell, but it kind of looks like the run animation's going. And the jump animation goes when I'm jumping up. Yeah, so there's the run. There's the jump. Okay, so we have something. We can start plugging in. So I'm going to take this frame size, and I'm going to put this for all the rest of my animations just to make sure that that's going to go. All right, now that I have that, let's go in here and see what we can do. First, let's see if we can scale down our image. Okay, so when we looked here, we could see that they were scaling. They're scaling the animation. Let's see if we can scale down animations. So look here and see what they have. They don't have a scale on this for part of the atlas. But I do see that it looks like we can talk directly to the animations instead of the animation to do stuff. So let's try that. We're going to try to scale down. Now I'm going to do some math as a starting point. We know that our frame sizes are 350, but our sprite is 50. So how much would we have to decrease by? 1/7. Okay, so that's what I'm going to do. So I'm going to do that. I'll scale down this sprite annies scale is and let's do a vector, create vector, and then let's do 1 divided by 7 comma 1 divided by 7. There we go, its size. Now maybe I might want it not as small. We can play around with the sizing. There's all kinds of stuff that we could do. What I want to definitely make sure though is that we have the majority of our object in the animation inside of our object. So I see his feet are kind of poking out the bottom, and then we have some space above here. And it's kind of in the middle instead of towards the edge. Since we have an infinite platform runner, we want them to be hitting on that spot. So I'm going to need to make some tweaks on that a little bit. So let's say I'm going to change sizes. I want to get a size that I'm kind of happy with. But now I'm farther down at the bottom. I'm going to need to scale this up. So let's look at the offset that they had. They had an offset. Let's try to do that too. We're going to offset. So we're going to say this dot sprite, and we'll just do it for all animations dot offset. We'll use another vector to pass two things. Now, what does it say for that? It says offset is the adjusted position of animation relative to the sprite's position. Okay, so I'm adjusting the offset of where the animation is, knowing that the sprite's animation or the sprite's position is that center crosshair right there. So I want to, let's say I want to shift it forward, let's say 50, and I want to shift it up, let's say 50, and rerun. Okay, he's poking out a little bit too much, but it looks like I'm getting it there. So maybe his size based off of what I want to do is a little bit too much. So I'm going to shrink him down a little bit. Okay, just a little bit over. That could be good. All right, I got to stop that rolling though. So now that is physics related though. So let's go back to our sprite, and we want to kind of think about this. Our sprite, we're building physics. Okay, so we have a circle, and a circle is hitting the ground. Which means that we're going to eventually have roll. We already played around with bounce. Now if we have a square, if we have low friction, it's not going to spin. It's going to move, easier. Now for a ball, a low rotation drag means that it can spin easier. A high rotation drag means that it spins more difficult. So that's kind of, it's not really friction between the ground and the object when it's a circle. It's how easy it wants to roll. Now let's look at rotation lock. No rotation lock. That's kind of what we have. With rotation lock, maybe we want to do that. So let's go ahead and do that. We also have drag force. So this is like the air kind of working against it when things fall. So we could use that. So let's put the rotation lock in. Now I'm going to do this for all of them because all of my colliders are going to end up having the same circle boxes. So all are circle colliders. All sprites dot rotation lock equals true. All right, now let's check that. I run, ooh, I slowed down. And it looks like, based on my size, I actually need to come down a little bit now that I can see it. So let's adjust them, not as much, maybe 30. I think we could even do a little bit more, maybe 20. Okay. We see him slowing down. I want to take off that debug though and see how he looks with that debug. So I'm just going to comment it out. Okay, he still looks like he's kind of floating. Now that could still be okay, but maybe you might want to adjust it where you have a less. That looks better to me. Looks like he's touching the ground. Okay, but him stopping is not good. Now that's probably because when we have rotation lock, it doesn't matter our force, we don't want to spin. That means we have to decrease our friction. So let's go ahead and decrease our friction. Now I probably don't want to have my friction be 100% zero, because then I'm going to be kind of sliding around all over the place. But we could also play around with our friction to maybe, if I wanted to be on like kind of like ice blocks or something like that. So let's do friction, and let's maybe put it as like 0.1. And as long as every state we kind of have it starting at a, what did I do? I saved it. All sprites dot friction equals, let's do 0.1. We run. Let's see if he kind of stops. He does eventually stop. Okay. So 0.1 would get me to eventually stop. So I can kind of keep adjusting it. So that looks better. Now I could go down to 0 and you can see what that would look like. I would suggest you want a little bit of little bit of friction. And this still technically works, but if he's ever holding still, like at the start, he's going to start kind of moving. See, he's kind of moving. But 0.01 or 0.001 means that friction is not 0. So I won't move. Okay. So that gives us, we've implemented our friction. We now are transferring our animation. See how easy that was to implement? Okay. Now for creating our hit and our dead, we do have that. We just haven't set it up because we haven't created a state like that. But hit and dead are two interesting states because they can happen during any one of these. So we might end up needing to deal with something like that. Or maybe our dead, we need to finish whatever animation we were in and then go to our dead animation, or anything like that. All right, so that basically is the end of us implementing these animations. If we needed to adjust the speed of these animations, we could use frame delay, but we had to scale the animations down. We had to offset it a little bit. We had to make sure that we were sizing a collider after we drew our animations. We had to make sure that we were passing a sprite sheet in. That is really how easy it is to do animations when we are reading the documentation and implementing based off the documentation. And setting it up by rows, because that's how it wanted it and made it easiest way was to do it that way. Okay, so that concludes this. Once you guys get the code done, you guys can go ahead and turn it in. And that's actually it. We didn't need to break it up into 3 because we did it all at once. So good luck. Have fun.